My name is Tiearea Sims, and I'm a doctoral student at California Intercontinental University. And today we'll be doing a presentation on linear regressions. The agenda for this presentation will be to define what a linear regression is, to give an overview of data being reviewed, to provide examples of simple linear regressions, give key takeaways, and also provide an area for asking questions. So, what exactly is a linear regression? A simple linear regression is a statistical method that allows us to summarize and study relationships between two continuous. The data set used for this testing was generated using a SurveyMonkey survey, which asked participants questions regarding their income, debt, savings, and other important personal finance factors. The sample regression test we will be conducting today will consist of three different tests. The first regression test asks, can we predict an individual's debt by knowing their income, with the dependent variable being debt and the independent variable being income? The second regression test will ask, can we predict an individual's savings by knowing their income, with the dependent variable being savings and the independent variable being income? The third regression test will ask, can we predict an individual's portfolio value by knowing their savings, with the dependent variable being stocks and the independent variable being savings? I was recording. For the first hypothesis test, we have a null hypothesis that states the regression coefficient is equal to 0, and an alternative hypothesis that states the regression coefficient is not 0. For this test, a simple linear regression was conducted to determine if we can predict an individual's debt by knowing their income. No significant result was found as a result, with a beta of negative 0.05, r squared of 0.00, with a p-value of 0.535, which is higher than our. The second hypothesis test uses the following null hypothesis. The regression coefficient is 0, with an alternative hypothesis that states the regression coefficient is non-zero. A simple linear regression was conducted to determine if we can predict an individual's savings by knowing their income using SPSS software. As a result, statistically significant regression emerged that showed a beta of 0.91, r squared of 0.82, with a p-value of 0.00, which is quite significant. Thus, the test rejected the null hypothesis and predicted aggression passivity scores, savings equaling 0.17 times income minus 203.47, which concludes that savings are predicted to increase as income increases. Further, the confidence interval of 95% does not contain zero, which furthermore supports the prediction. The third hypothesis test uses a null hypothesis that states the regression coefficient is 0 and an alternative hypothesis that states the regression coefficient is not 0. Again, a simple linear regression was conducted to determine if we can predict an individual's portfolio stock by knowing their savings. As a result of using SPSS software, a statistically significant regression emerged, with a beta of 0.16, r squared of 0.08, with a p-value of 0.00, which is significant. Thus, the test rejected the null hypothesis and predicted aggression passivity scores, with stock equaling 0.16 times income plus 1006.73, which indicates stocks are predictive to increase as income increases. Furthermore, the confidence interval of 95% does not contain zero, which supports the prediction. Key takeaways of this presentation consist of knowing that a simple linear regression is a statistical method that allows us to summarize and study relationships between two continuous variables. P-values that are below the significance level indicates a regression, and that confidence intervals that do not include zero will help to support the prediction. Please feel free to ask any questions if you have them at this time, and thank you for watching this presentation.